Students, so we'll discuss a few in-text questions of the chapter alcohols, phenols and ether. Okay, so first let's look at this question. Show how are the following alcohols prepared by the reaction of suitable Grignard reagent on methanol. So this is the alcohol. Okay, show how are the following alcohols prepared. So this is the alcohol prepared by the reaction of suitable Grignard reagent on methanol. So the reaction is between methanol and Grignard reagent. Okay, what's the Grignard reagent? I have told you many times Grignard reagent is of the format, you write it in the format RMGX. Okay. Okay, where R is the alkyl group, Mg magnesium and X is the halide. What are halides? Fluorine, chlorine, bromine, iodine, all these are halides. Okay, so Grignard reagent basically is RMGX. Okay, and then on methanol. Okay, what is Al? Al meaning it has an aldehyde group. Okay, Al meaning it has an aldehyde group. Okay, and you know what is an aldehyde group? Aldehyde group, it is C double bond OH. Okay, and now meth meaning it has one carbon atom. Okay, so this meth meaning it has one carbon atom already you have written, and you have that carbon atom from this aldehyde group. So you don't have to add further carbon atoms because meth meaning it has one carbon atom and already it has a carbon atom for aldehyde. Okay, so now you fill the rest with hydrogens. Okay, so I hope from the name you got how do you write the structure. So methanol, Al meaning aldehyde, and aldehyde is something which has C double bond OH group, and meth meaning it has one carbon atom. So already you have one carbon atom because it is an aldehyde. Okay, then you fill the rest with hydrogens. So now when you look at this, it is basically formaldehyde. Okay, so methanol is basically formaldehyde. So you need to write the reaction having this formaldehyde with Grignard reagent. So you will write this Grignard reagent in a general format with R, and then from the product what you need, you recognize what is R. Okay, so now we'll write the reaction of this formaldehyde with Grignard reagent. So here you can see this is a formaldehyde with a Grignard reagent. Okay, so here in Grignard reagent you already know, I have already told it in the previous video like preparation of alcohols. R will be having a slightly positive charge, slightly negative charge. So R will be having the negative charge, magnesium will be having the positive. Okay, so R minus Mg plus. So this R minus will be attacking the carbonyl carbon. Okay, this is how you write carbonyl carbon. So this R minus will be attacking this carbonyl carbon. This O minus, the negative charge will go to the oxygen. Okay, so it forms an adduct and then hydrolysis takes place, and what you see, this O minus MgX becomes OH. Okay, by hydrolysis, and here the R group from the Grignard reagent. So this is the product RCH2OH. Now look at this product. Okay, here you have the CH2OH and here you have the CH2OH. So what is this R group? R group is the rest of this group. Okay, so from that you can understand what must be this R in this Grignard reagent. So what would be that R? R is basically CH3 CH3. So this is basically the R in Grignard reagent. So how will you write the reaction with this? So this is basically the R in the Grignard reagent. So we'll write the reaction with this R group. Okay, Okay, now we identified the R group in the Grignard reagent. Okay, R and RMGX. So what is R and RMGX? Okay, so this is the group CH3, CH3. Okay, now the reaction with formaldehyde, HC double bond OH. The here you will have the negative charge. It will be attacking this carbonyl carbon, and finally you will be getting this product. Okay, you can see this product is same as this. Okay, this is how you identify what is R in RMGX when this is a product. Okay, now let's look at this. This is also the reaction with formaldehyde with Grignard reagent. Now we need to find what is R in RMGX to get this product. Okay, so here you can see CH2OH, CH2OH, it is same. Then what is the R group? R group is a cyclohexyl group. Okay, R group is a cyclohexyl group. So what did you understand? In this case, in the second case, R will be this. Okay, to it MgX will be attached. So we'll look at the reaction. Okay. Okay, so now you got this product and you can see this product is same as this product. Okay, CH2H, CH2H, cyclohexyl ring attached, cyclohexyl attached. So here what was the Grignard reagent? To this MgX, R group is a cyclohexyl. Okay, and so this negative charge will be attacking this carbonyl carbon. Okay, then the negative charge, basically the alkyl group, basically the alkyl group will be attacking this carbonyl carbon. This negative charge will shift to oxygen, O minus MgX. Then water, additional water, basically hydrolysis. Okay, and this becomes OH. This is the adduct and this is the product. Okay, so from this we recognize what is R and RMGX for both the products. Okay, so I hope this first question is clear for you. Then moving on to this next question. Okay, here you can see. First question is done. Then in this question you can see this is an alkene. See, when you have a double bond, see you have double bond. So this is an alkene. Okay, alkene, then H2O H plus. Basically this is an unsymmetrical alkene. You know what is symmetrical alkene and what is unsymmetrical alkene. Basically the R group attached to this this is a double bond, right? So this R group and this R group is different, so you call it as unsymmetrical. Okay, in the case of unsymmetrical, so this is a case of unsymmetrical alkene, and the reagent is H2OH plus, so it will be following Markovnikov addition. Basically you have learned Markovnikov addition previous, like in the previous videos you can see, like when you have HBr you write Markovnikov addition, and when you have hydrogen peroxide you have anti-Markovnikov addition. Okay, so now just remember this. Here you have H2H plus, so Markovnikov addition. Okay, in Markovnikov addition basically hydrogen will add to the carbon having more number of hydrogen atoms. Okay, so basically this water, you can write this water as H plus and OH minus. Okay, so this hydrogen, see this water you can write as H plus and OH minus, right? So this hydrogen will attack to hydrogen will add to carbon having more number of hydrogen atoms. Okay, so here these two are the carbon atoms. So this carbon has more number of hydrogen atoms, so this hydrogen will come in this position and this OH will come in this position. Okay, so or another way what you can do is you can split in the sense you can break this bond. Okay, and distribute the positive and the negative charge. So one carbon will be getting positive and one carbon will be getting negative. It can be also the other way, right? Negative here and positive here. But why do we break it in this way? Because carbocation, carbon and positive charge. Carbocation, which is tertiary, is more stable, then secondary, then primary. So when you break in this way, this is secondary. So secondary is more stable than primary. So if you have, if you split in a way that you get positive over here, what happens is it becomes primary carbocation. but primary carbocation is less stable compared to secondary. So secondary is more stable, so you break in such a way that you get secondary. So basically you break the bond in such a way that to form a stable carbocation. So you break it here, there's a chance for formation of secondary carbocation. So you break in such a way that secondary carbocation is formed. Okay, so here you get CH3, CH2. Okay, then here you have H plus. So basically this H plus will come here and OH minus will come to this carbon having positive charge. Okay, so this is how, if you want to break the bond and write, this is how you can write. Otherwise, blindly you can write it. Okay, hydrogen will be attacking carbon having more number of hydrogen atoms, and the other one will be attacking the other carbon. Okay, so now how will you write this? Okay, so now this is the product. Okay, now you can name it like 1, 2, 3. Okay, 1, 2, 3, 3 carbon atoms. So it is, you get the name propane. Okay, propane, 3 carbon atoms, so propane. Okay, so here in second position you have OH. Okay, when you have OH, you give the word as all. Okay, so you write it as propane to all. Propane because there are 3 carbon atoms in the chain, alkyl chain, and in second position you have OH. So when you have OH, you give the name all, OL, all. Okay, so to all in second position, so it is to all. So propane to all. Okay, that is a product. So moving on to the next question. Okay, here what you have a reactant, then you have NaBH₄. Now what is NaBH₄? What is NaBH₄? NaBH₄, you call it as sodium borohydride. Okay, sodium, I hope you, okay, sodium. Okay, so NaBH₄ is sodium borohydride. Okay, and what does this NaBH₄ do? NaBH₄ is a reducing agent. Okay, basically it gives hydride. Okay, hydride ion, basically H minus. Okay, so basically it will be donating H minus. H plus is proton, H minus is hydride. Okay, when you say H plus, you say proton is released. When H plus is released, proton is released, and which H minus is released, you say hydride. Okay, so here NaBH₄ is a hydride donor. So NaBH₄ is a reducing agent. What is a reducing agent? Basically it will be reducing. Basically if substances which reduce. So here you have oxygen. So basically it will remove reducing. Basically it will be causing reduction. So basically what happens if it has it can be removal of oxygen or it can be addition of hydrogen. All these happens when there is reduction. So reducing agent is something which causes reduction. Okay, NaBH₄ is a reducing agent. So NaBH₄ is a reducing agent. So reducing agent, what does it do? It causes the reduction of the reactant. Okay, and what is reduction? Reduction is basically removal of oxygen or addition of hydrogen. Okay, and so in this case NaBH₄ is a reducing agent. So NaBH₄ is sodium borohydride. It is a reducing agent. So it is a hydride donor. Okay, so what does it it will be reducing aldehydes and ketones. Okay, and what is aldehyde? Aldehyde, I told you, it is C double bond OH. That is okay. Basically C double bond OH is the aldehyde group, and this R can be hydrogen or any alkyl group. That is the aldehyde. And what is ketone? Ketone is basically RC double bond O R. Okay, so basically it will be reducing, NaBH₄ will be reducing aldehydes and ketones. Okay, aldehydes and ketones. So this is the keto group. Okay, you have C double bond O, here alkyl group, here alkyl group. Okay, alkyl group is basically carbon attached to the rest hydrogens. Okay, so that is the alkyl group. So here you have R group, here you have R group, then here you have carbonyl group. So this is the keto group, ketone. Okay, And here what you have, C double bond O, O, CH3, C double bond O, O, R. Okay, so this is basically the ester group. I have told you NaBH₄ will be reducing aldehydes and ketones. Okay, so since this is an ester group, it won't be reducing this ester group. Okay, so it will be reducing the keto group. So when you get a question, you need to see if there is an aldehyde present or ketone present. Okay, so it will be reducing that, and the rest won't be reduced. In this case, this is an ester, so it won't be reduced. So it will be reducing this keto group, okay, to alcohol. So since it is ketone, it will be reducing to secondary alcohol. If it was aldehyde, it will be reduced to primary alcohol. I have discussed this in detail in the video like preparation of alcohols. Okay, so if you have any doubt, you can look, you can go and watch that video. Okay, so here look at the reaction. Here what you have, keto group, ester group. This is the ester group, this is the ketone group. Okay, ester, this is the ester group, this is the ketone group. Okay, so I told NaBH₄ will be reducing ketone and aldehyde. Okay, so here what you have is ketone and ester, so it will be reducing ketone. So here you have C double bond will change to OH. See, here you got OH. Okay, the rest will be the same. The rest is the same. Okay. Now, how are you going to name it? Okay. Other important thing is you need to name it. So here you have the ester. This is the ester group. I have told you already. So how are you going to name it? So first, what you need to see is here there are two oxygen atoms, right? You need to identify the oxygen which is attached to two carbons. Okay. So here this oxygen is attached to only one carbon. Okay. Here this oxygen is attached to two carbon. So this is the oxygen. Okay, so you need to identify this oxygen. Basically, first step, you need to identify the oxygen which is attached to two carbon atoms for this ester group. So here this is that oxygen because this is attached to this carbon and this carbon, to the carbonyl carbon. Okay, now you number this. First you need to number the alkyl group which is attached to which is further away from the carbonyl group. Basically here you can see, here there is an alkyl group, here you have an alkyl group. So first, will you start numbering this one or this one? So first, which one will you name it? So first you need to name the alkyl group which is far away from this carbonyl group. So this alkyl group is far from this carbonyl group. Okay, so first name this. So here you have one carbon atom, so name it, and then you need to start number these carbon atoms. So here you have two carbon atoms. Okay, then you can number this. Okay, so here you can see. So how are you going to name it? Here this is the methyl. So first I have told you need to like the alkyl group which is far from the carbonyl group must be named first. So here you need to name this group first. So this is methyl. Okay, so this is methyl. So first you will have methyl. Okay, and then you have two carbon atoms. When you have two carbon atoms, what you call ethane. Okay, you have ethane. Now you have two oxygen atoms, like this is basically an ester, right? So in the case of ester and in case of salt, you replace this E with O8. Okay, basically when you have an ester or you have salt, you name it with O8, O8, okay. So basically it is ethanoate, so methyl ethanoate. Okay, this is how you name methyl ethanoate. And I'll give one more example. For example, so consider this case. In this case, what I tell you, like when you name ester, first you need to find, here you have two oxygen atoms, but you need to find the oxygen atom which is attached to two carbons. Okay, so here this oxygen atom is attached to two carbons, but this oxygen atom is attached to only one carbon. So this oxygen attached to two carbons, so consider this oxygen atom. Okay, this is the oxygen atom. Now then you need to name the alkyl group which is far from the carbonyl group. So this is one alkyl group, this is one alkyl group. So this alkyl group is far from this carbonyl group. So you need to start numbering this carbonyl group. So first you need to consider this alkyl group. Okay, so here 1, 2, 3. This is carbon, this is carbon, this is carbon. This is basically CH2, CH2, CH3. Okay, so then you number this. So here we have 1. So as I said, first you need to name the alkyl group far from the carbonyl, alkyl group which is present far from the carbonyl group. So here you need to name this. So here you have 3 carbon atoms. So you end up with the name propane. Okay. So basically it will become propyl. Okay. Propyl. And then here you have 2 carbon atoms. So when 2 carbon atoms, ethane. So since this is an ester, you write ethanoate. Okay, so it will become propyl ethanoate. I told you E will be replaced by O8. So 3 carbon atoms, propyl, 2 carbon atoms, ethane. Since this is an ester, O8. Okay, so similarly here methyl ethanoate. Methyl, then 2 carbon atoms, so ethane. So since this is an ester, you replace with O8, so methyl ethanoate. Okay. Now again you have other group attached to it. So 1, 2, 3, 4, 5, 6. What is this? This is a cyclohexyl. Okay. In the second position you have OH. When you have OH, it is basically a hydroxy group. Okay. So you write 2 hydroxy cyclohexyl. Okay. So what do you write? Methyl, then 2 hydroxy cyclohexyl ethanoate. So first you write methyl ethanoate. Okay, this is methyl, this is ethanoate. Methyl ethanoate. In bracket you write second position OH. So 2 hydroxy cyclohexyl ethanoate. I hope this naming is clear. And then we look into the next question, which is same. You have NaBH₄. I told you NaBH₄ is a reducing agent. It will be reducing aldehydes and ketones. So here CHO is the aldehyde group. Okay, CHO is the aldehyde group. So it will be reducing the CHO. Basically it will be existing like C double bond O and H, and this is the R group. Okay, so C double bond O will become COH. Okay, so how do you write the product? basically, how do you number it? You number it 1, 2, 3, 4. You can number it in this way, or either you can write it as 1, 2, 3, 4, or the reverse order. And why did you number it in this order? Because the functional group OH must be getting a lower number. Okay, lower number. So 1 and 4, so 1, it should get 1. Either you can get 1 for this carbon atom, or you can get 4 for the carbon atom. So this OH must be getting a lower number. So in this way, that is the reason why we numbered it in this way. So 1, 2, 3, 4. Okay, in second position you have methyl. Okay, so 1, 2, 3, 4. So bute. In first position you have OH. So butanol, or simply as butanol. In second position you have in second position you have methyl. Okay, so 2 methyl butanol, 2 methyl butanol. So